Okay, this is the Vika Academy, and we are looking at service integrals. This is a vector analysis course or else topic, and it's very important. Remember to subscribe if you have not yet subscribed. Remember also to share with your friends if you have not yet shared the previous tutorials. So welcome. Today we want to look at service integrals. Service integrals. So let S be a two-sided service, and let one side of S be considered arbitrarily as positive signed. If S is closed service, this is taken as outer service, the outer side. A unit normal N to any point of the positive side S, we call it positive or outward drawn unit normal. Outside drawn unit, outward drawn unit normal. So this is what we are saying. We are having this kind of cylinder here with a normal N. So this is a normal N, and this is the distance ds. So in this we are saying this is a two-sided service, and we are saying one side is considered the positive side. And if we are talking about this service being closed, then we say S is closed service, and we take the outer side, S as outer side. And if the unit normal N to any point, and the point here is this one of the positive sign S, is we call it the positive or outward drawn unit normal. So this is the outward drawn normal. So associate with the differential of the service area, and the associate with the differential of service area is what we are calling ds. Vector ds is a vector ds whose magnitude is ds, and direction is that of nds. So that if we say that, we mean that if we get the double integral of nds will be same as saying taking the double integral of the service ands. These two are known as service integral, and also this represents what we call the flux of A over S. So this is generally the flux of A over S, which is the double integral over S of A ds. This is same as also the double integral of A nds. So that is it. That's what you call service integral. It is a double integral used over planes to calculate areas of regions with curved boundaries. So if we have a region with curved boundaries over a given plane, we use the double integral, which we call service integral. We also use this to calculate moment, that is application in physics. We also use this to calculate mass, and also the centers of the mass. So that's the key application of service integrals. If you have any question or any comment that you need to leave, kindly leave it down there at the comment point. And if you have any elaboration for that you need to leave on expansion on this, you can also leave it down there. And again, remember to subscribe. I'll be grateful. Okay, having noted that, we can look at an example. And we want to evaluate. Let's evaluate double integral x y squared dx dy. So this is a surface integral. It is a plane surface xy divided by xy. We want to know the area, the surface area for this. So in this we are having from 0 to 3, from 0 to 1. So you first start operating from the nearest, which is the dx. So we hold y the constant and we integrate in respect to x. So that will give us the integral from 0 to 1. X, if you integrate this, x becomes x squared divided by 2. Okay, then y squared dy now. But now this is running from 4x is 0 to 3. So if you substitute this, you'll see that we are having the integral from 0 to 1. When x is 3, we have 9 over 2 minus, when x is 0, we have 0 here. Then y squared dy. So what are we having here? We are going to have the integral of from 0 to 1, 9 over 2 y squared dy. So we have solved the first part for dx. Now let's integrate this in respect to y. So we'll have 9 over 4 okay, 9 over 6 2. Okay, yeah. Okay, we can do it this way. Let's factor out 9 over 2 outside to make it quite quicker. Okay, so we'll have 9 over 2. If we integrate, we'll have y over 3 over y power 3 over 3. Okay, and it's from 0 to 1. Oh yeah, that's a bit clearer. So if you substitute 1 there, you'll have 9 over 2 by what? By 1 over 3. And you can see this gives you 3 over 2. So if you have a question on this, you can leave a comment and I will be able to check on it. Remember to subscribe if you have not yet subscribed, and also to share with your friends. Until next time.